Good morning and happy Tuesday. Tuesday. Why am I saying it like that? Tuesday. Well, why do math teachers like Tuesday? It's the only day named after a number, Tuesday. And check this out. This Tuesday is the second day of the second month. It's 2 Tuesday, right? Gotta love stuff like that, right? Because you do, huh? You don't want to admit it because you think your friends will teach you, but you love that stuff, huh? Yeah. All right. Have a good day, everybody. Copy this down. Go do it. Come back, right? When you're comparing these, what does that mean? You are saying greater than or less than. And remember, this symbol is the one that you can turn into the word less if you want, right? Left hand makes that symbol less than, right? So remember that it's going to point to the smaller number. Point to the smaller number. Do those, and don't forget on these, do the same thing to the other side. You can do anything to one side. If you do the same thing to the other, it stays in balance. Try to show an extra step in here versus skipping a step. Slow is smooth, and smooth is fast. All right, we'll see you in a bit. And that was a quick bit. Here we go. 42 and 13, most popular diamond ever. What works there? 7 times 6 or 6 times 7. 52 and 17. I recognize 52. I like finding numbers in real life. Where do you find the number 52? Well, there's a couple different places. There are 52 weeks in a year. You know that? But there's also 52 cards in a deck. You ever have an older brother, older sister say, hey, you want to play 52 pickup? Say, sure, my older brother wants to play with me. And then they throw a deck of cards on the floor and say, pick them up. Yeah, mean older brothers. Yeah, I didn't have an older brother. I was older brother, but I wasn't mean. You know, Mr. Daniel's nice. All right, like that pen, huh? All right, can't quite see it. I'll bring it down a little bit. Okay, 52. So 52 cards in a deck, right? And it looks like there are 13 cards in each suit, right? Clubs, diamonds, those are suits, right? Ace through 10, and then Jack, Queen, King is 13. So 4 times 13 is going to be 52, and 4 plus 13. Okay. Finding numbers in real life. Love it. All right, how about this one? This is actually going to be 6 tenths, and 2 more tenths is going to be 8 tenths, right? When you add those, you stack them, line them up. The 2's underneath the 6. Decimal comes straight down. When you multiply, go 2 times 6 is 12. But I had to move that over one spot to pretend that was a 6, and move this over one spot to pretend it was a 2. That's 2 spots in my problem. I moved decimals over, so I have to go back 2 spots in my answer. Now, don't get confused and say, oh, there's 2 decimals. No, it's how many spots. Because sometimes one decimal, you can move it over 3 spots in one decimal. Okay? So make sure you're counting the places you had to move the decimal in your problem and going back that many spaces in your answer. 4.5, 4.5. You messed up, Mr. Daniel? You must have, because I can't figure this out. Well, some of you figured it out. I stumped most of you. But some of you figured out that 3.5 is 3 ones is 3. 3 halves is 1.5, right? $3.50 is $1.50. 3 half pizzas is 1.5 pizzas, right? So this is 4.5 when I add and 4.5 when I multiply. Kind of cool. I like finding those. Okay, you could find more of those for me. Let me know. 3/8. When I want to change this to a decimal, what do? Hopefully you're yelling out, divide the bottom into the top. Duh. You already told us that, Mr. Daniel, like 100 times. All right, add a decimal, bring it up. 8 goes into 33 times because that's 24. When I get a 6 for remainder, I'm going to add a 0. And 8 goes into 67 times because that's 56. When I get another remainder, I'm going to add another 0. And 8 goes into 40, nice even 5 times. So 3/8 is the same as 0.375 or 375 thousandths. How do I change from a decimal to percent? That's one of the easiest things ever. You move 2 spots, right? If I'm changing from decimal to percent, it's 2 spots that way, 37.5%. If I'm changing from percent to decimal, it's 2 spots that way, 0.375. Pretty cool, huh? Now, 8s aren't that bad to draw pictures of, right? You go half, Then you go half of a half is a fourth. And let's cut those one more time and make sure everybody gets a slice of pizza. Mr. Daniel gets 3, though. Okay, 3/8. 125 thousandths. Move it over 2 spots. I get 12.5%. Write this as a fraction by putting every number to the right of the decimal to on top, put zeros under each of them, and then put a 1 in front. Okay, so 125 thousandths, which is what we called that anyway. If you say it correctly instead of saying 0.125, that's kind of cheating, right? All right, now I know that 25, I know 5 is going to go into each of these, but I actually know 125 times 2 is 250. 250 times 2 is 500. 500 times 2 is 1,000. So 125 goes into 1,000 8 times. This is actually 1/8. Okay, you only get 1 slice. You get 1/8. I get 3/8. Uh-oh, I messed up, didn't I? 37.5%. Oh, we already know that's going to be 0.375. Hurry up. Get all the answers before Mr. Daniel changes his mind and makes this harder. Right? Yeah. Sorry about that, guys. I know you came here to get a nice fortified breakfast. Someone snuck a cookie in there or something easy and sweet. It's not so good for you. That's not good for you. It's already done for you. You got less work. I'm sorry. You'll get more fortification, more healthy food tomorrow. Okay. All right. On to comparing 3/7 and 3/8. Okay. Now I can get a common denominator and say 3/7 is the same as how many 56? Well, I did 7 times 8. I go 3 times. That's 24/56. And 3/8 is the same as how many 56? I did 8 times 7. So I go 3 times 7 and say 21/56 is less than 24/56. So it points to the small one. But check this out. I have the same denominator, so I know I'm getting 3 slices here. Okay. Now, this one, I only cut into 7 slices. I'm sharing with 7 people here, sharing with 8 people here. You share with 7, you get more than if you share with 8, right? So I didn't really even have to, if I'm adding those, I do have to get common number. But if I'm just checking to see which is bigger in the slices, the number of slices I get is the same. I just have to figure out which slice is bigger, 1/7 or 1/8. And 1/7, I'm getting 1 slice after I cut it into 7 slices, right? Think to the extreme there. If I only cut it into 2 slices and I got 1 slice, I got half the pizza, right? If I cut it into 100 slices and only got 1 slice, I'm getting a little sliver, okay? So the bigger the denominator, the more slices they are, the smaller pieces there are, okay? So I can quickly say 2/5 versus 2/3. 2/5 is smaller, right? And I think most of you can visualize 2/3 being more than half and 2/5 being a little less than a half. Okay. Now you can compare by getting common denominators and say 3 and 5 go into 15. 3 times 5, 2 times 5. 5 times 3, 2 times 3, and say 6/15 is smaller than 10/15. Right? You can do that, right? But you have to. Now on this one, I'm just going to get close, right? If I double the top and bottom, multiply it by 1, 2 over 2, 1/8 is the same as 2/16. And now I got a number that's kind of close. 2 slices cut into 16 is going to be a little bit bigger than 2 slices cut into 17. Okay, 2/17 is less than 1/8. 3/8 and 3/7. Which slices are bigger, a 7th or an 8th? And sorry, I gave you another cookie, didn't I? 3/7, 3/8, 3/8, 3/7. Oh man! All right, make sure you have them pointing in opposite directions, right? Because the 3/7 is on the left side here. The 3/8 on the left side there. Okay, so 3/7 is greater than 3/8. 3/8 is less than 3/7. Remember, you can make, if it's pointing that way, you can make that into an L and say less. Now 5/17. I'm doing a similar thing here. Okay, I'm going to go ahead and multiply the top and the bottom by 5, right? That's multiplied by a magic 1. I'm allowed to multiply by 1. It doesn't change its value. Just sort of renames it something closer. So 1 times 5 and 3 times 5. Now I have 5/15ths here and 5/17ths here. So I'm getting 5 slices either way. Which slices are bigger, a 15th or a 17th? Well, 15th is a little bit bigger. So 5/17ths is less than, a little bit smaller than 1/3. Same idea here. I'm going to multiply the top and bottom by 4. I get 4/8. 4/8 is a little bit bigger than 4/9. 4/9 is less than. Here I'm going 2 over 2. 2/8 versus 2/7. 2/8 is a little bit bigger, right? Sharing with less people. Slices are a little bit bigger. And here I'm doing the same thing. 8 times 2 is 16. 50 times 2 is 100. 1700ths is a little bit bigger than 1600ths. Cool way of comparing fractions, right? You just need to know which one's bigger. Okay. Now, if you have to know how much bigger, that way you're getting the difference, right? How much bigger is the difference? How much bigger is 7 than 3? It is 4 bigger, right? I'm getting the difference. So if you're getting the difference, you know how much bigger or smaller something is, then you do have to get a common denominator and subtract. Okay, all right. When we're solving algebraic equations, our goal is to get the variable, the letter on one side of the equal sign and numbers on the other. You've solved it, right? You have an answer. X equals something. A equals something. What's it called when we put the variable all by itself? Put it on an island all by itself. That's isolate. And why did I say an island? Well, if you are on an island by yourself, you are isolated. And ISLA, isla, is how you say island in Espanol. And in English, you have a silent S and you spell island, ISLAEND. So ISLA comes in all three. Put those together. It helps you spell island. It helps you learn a little Spanish. And it helps you remember what you're doing when you isolate a variable. You're putting it on an island by itself. Now, what do I have to get rid of to get this X all by itself? A lot of you will say 2.02. You have to get rid of a 2.02, which is almost all the way right. But what are they forgetting if they say get rid of a 2.02? They're saying you have to get rid of a minus 2.02 because that leads you to the next step. Okay, our goal is to isolate the variable. The next step is to use the inverse operation, right? Remember what the inverse is? That's the opposite. What is the opposite of minus 2.02? Hopefully you said plus 2.02. However, you had an equation that was in perfect balance, and now you subtracted, or you added 2.02 to this side. That puts it out of balance, right? Puts a little heavy on this side. It's going to be leaning. You want to get it to stay in balance. You do the same thing to the other side. What does that mean? I have to add 2.02 to this side as well. If I add, I can do anything to one side if I do the same thing to the other. Okay? Now, these two things cancel each other out. They're opposites. All that's left is X on this side. And on this side, I have 6.1, 6 and 1/10, plus 2.02, 2 and 200ths. Go at them, stack them, line up the decimal. All right, now that looks a little weird because this comes out to the hundredths place. This only comes out to the tenths. Let's add a 0 so it doesn't look so weird. Okay, you're allowed to. Decimal comes straight down. You add or subtract. 0 and 2, 1 and 0, 6 and 2, 8 and 1200ths. And do not go celebrating too soon. Are you finished? No. But I have the answer, Mr. Daniel. It's right there. Yes, but what should you always do on an algebraic equation to make sure? You check. If X equals 8.12 or 8 and 1200ths, then I should be able to substitute 8 and 1200ths in for my original problem and prove that this is true. 8 and 1200ths, 2 and 200ths, stack them, line up the decimals. Decimal comes straight down. 12 minus 2 is 10. 8 minus 2 is 6. 6 and 10 hundredths are 6.10. It's the same as 6.1. Is that what we got? Now you're done. Pat yourself on the back, do a end zone dance, spike the football, whatever, right? Hey, Super Bowl Sunday, huh? All right, let's do this next one. 4A, what does that mean? 4 times A. So the first thing I do here is I reverse those because I want the letter to start my problem if I can. And I'm going to write that times sign. 8 times 4, A times 4, plus 3 equals 31. I know I want to get the A by itself. What am I getting rid of? I have to get rid of a times 4 and a plus 3. Now, this is where slow is smooth, smooth is fast bumps in, right? And this is where, if you heard me last week saying, if you have more than one operation, go in reverse order of operations, right? What's the simplest one? Get rid of that one first. What's the simplest thing there? Simplest thing is a plus 3, okay? How do you get rid of a plus 3? Do the inverse operation, right? Now, what's the inverse operation of plus 3? Minus 3. And I'm going to write DTSTTTOS. Do the same thing to the other side. So subtract 3 from this side, and I just wrote that. Subtract 3 to the side. What's left over here is A times 4. The plus 3 and minus 3 cancel each other out. And over here I have 31 minus 3, okay, which is 28. Now I still have to get rid of a 4, not just a 4, but a, hopefully you said times 4, right? And what is the inverse operation of times 4 divided by 4? If I do it to this side, make sure you do it to this side. Okay? Now, times 4 divided by 4, they cancel each other out, right? If you make something 4 times bigger and then divide it by 4, you're back where you started, right? You ever see that movie, Honey, I Shrunk the Kids? Oh, gotta rent it. Funny old Disney movie. Rick Moranis, he's a mad scientist, and he accidentally shrinks the kids, and they have to get from the mailbox in front of the yard, and they're tiny, through the grass up to the house. And they're tiny, so tiny that when they see an ant, they're like, oh my goodness, he's going to eat us, right? When the sprinkler goes on, the water droplets are like huge water bombs, right? Great movie. Anyway, they made a sequel, Honey, I Blew Up the Kids. Meaning if they exploded, it means that they enlarged. So that's one thing that comes to mind when I think of times 4, made it 4 times bigger, then made 4 times smaller, back to normal, right? That's kind of what he did in the movie. Now, what is 28 divided by 4? How many times is 4 going to 28? That's a basic fact, right? 7. Are you done? Hopefully you said, no, go substitute. I should be able to say 4 times 7 plus 3 equals 31. Now, 4 times 7 is 28. Is 28 plus 3 31? Yes, now you can celebrate, right? All right, good job starting your day. Sorry for the length of this, but that was a lot to talk about, huh? All right, have a great day, everybody. We will see you soon.